Hello guys, this is Raj and welcome to my YouTube channel. Please like, subscribe and share with your friends if you like this particular video. Uh, so today we are going to study about measures of the central tendency. So measures of central tendency are the mean, median and the mode. Though we have covered these kind of topics in our school days as well, but today we are going to look at these data, these topics, the measures of central tendency in a very uh, different perspective. Let's have a different perspective altogether to look at mean, median, mode in the data science world. How do we calculate these three different terms or these central tendency? Okay. So we'll start with the mean. Mean is the average of the numbers. So whatever the numbers are there, if you have around 3 or 4 numbers, just sum those numbers together and divide by the count of the numbers, right? Median is the middle point. Median, if you have referred to my previous slides, then in the previous slides, even I have talked about median, and it is the 50 percentile, 50 percentile. So it is the median, it is the middle point. It is nothing but the, if you have got the set of numbers, then you need to arrange those numbers in the ascending order and then find the middle point, right? So that is median. And mode is nothing but the maximum frequency in a set of data, in a given set of data, which is that number which is coming maximum times, which has got the maximum frequency. So that is the mode of a particular data set. It can be multimodal as well. I mean, you can have more than one mode to a particular data set, right? So let's have a look at, I mean, in detail, let's calculate these mean, median, mode. So this particular example in below shows 18, 22, 15, 10. So these are the numbers. And if you look into these 000s, then these are the frequency, which means 18. Number 18 is 1, 2, 3, 4, 5, 6, 7, 8. So 18 is 8 times, right? 22 is 3 times. 15 is 1 time. 10 is around 5 times. 5 is 7 times. There is no occurrence of 9 and 7 here. 23 also there is no occurrence. 19 is 2 times. 4 is again 7 times. 8 there is no occurrence. 13 is 4 times. 1 there is no occurrence. And 21 there is 1 occurrence. So 21 has occurred 1 time. So you have to calculate the mean of this particular data set, right? So altogether in the data set there are 38 numbers. If you sum total these particular zeros, then you will find out that these are the 38 numbers in total. So let's calculate the mean first. So if you see this, how many times 18 has occurred? 1, 2, 3, 4, 5, 6, 7, 8. 18 into 8. So that's what I have done here. 18 into 8. 22 is 3 times, right? This 22 is 3 times. So I have written 22 into 3. Then 15 is once. So 15 into 1. 10 into 5. So 10 into 5. 5 has occurred 7 times. 5 into 7. And so on. We have completed the entire data set. So and divided by 38 because this entire occurrence of different numbers is actually 38. So that's what I have divided by 38. And then if you sum all the numbers and then divide by 38, it comes out to be 11.81. So this is the mean of this particular data set. So if you say this is a data set, this is a data set, and the mean is 11.81. What is the mode? So mode I have already talked about. This is the maximum frequency, maximum occurrence of any particular number. So if you see, this is 8 times. So this is the maximum occurrence. So which is that number which has come with the highest frequency? So 18 is the number. So mode becomes here 18. So that's how mode is calculated, right? Suppose if you omit this particular number, if you do not have this particular number, then this occurrence is 7, this occurrence is 7, and this occurrence is also 7. So it becomes multimodal. So in that case, if somebody asks you what is the mode of this particular data set, then it is a multimodal data set. It is a multi-mode, and the modes are 18, right? Then we have 5, and then we have 4. Okay. So in that case, the modes are 18, 5, and 4. So this is mode. In median, what we have to do is we have to arrange all the numbers in an ascending order. Due to the huge 38 count, let's take a very simpler example in our next slide. I've just removed few of the occurrences to make it a very simpler exercise here. So here also 18 there is no occurrence, 22 we have 3 occurrence, 15 1, 10 we have 5, and so on, right? 9 7, then 1, then 8 we do not have any occurrence. And what I have done is I have just arranged the entire data set into ascending order. So this is an ascending order. Okay, so this is an ascending order. Okay. And now try to find out the middle number. So this is 10, okay, and this is 10. So here we have taken 10, here also we have taken 10, and this is your middle point. Okay. So the median comes out to be 13. So this is the median. Suppose the number, so these here the count of the numbers are odd. The count of the numbers are odd. Here n is equal to 21. If you calculate the sum, then 1, 2, 3, 4, 5, 6, it comes out to be 21. And that is why you have got the middle point. Suppose the count comes out to be, suppose the n is even. Here the n is odd. Okay. Here the n is odd. Suppose the distribution of the numbers is in such a way, let's take a very even count. So let's 2, 3, 4, 5. Okay. So these are 4 numbers and you have to find the median of this number. So how many n? So n is here 4, which is even. So in this case, what will be the middle point? You remove this, this comes out to be the middle point. Okay. So in this case, what you have to do is you have to take the average of these numbers. So what you have to do is 3 plus 4 divided by 2. So this comes out to be 7 by 2 and it will be 3.5. Okay. So this is how median is calculated, and the technique here is that if n comes out to be an even number, then you'll have to take the average of the middle numbers, and that's how you will get the median. So this was mode, median, and mode. Let's take a very special consideration. Here mean is equal to mode is equal to median. Here all the mean, median, and mode are equal. Why? So this is a very symmetric distribution of the numbers, right? This is a very symmetric distribution of the numbers. So if I draw a line from the center, what is happening is the left distribution is exactly symmetric to the right distribution. So this is your right distribution. So this is your right distribution, okay, and this is your left distribution. The left distribution is exactly similar to the right distribution. Okay. So here the mean, median, and mode is this one. Whatever number is lying here, say suppose this is 5, 6, 7, 8, 9, 10, 11, 12, and 13. So in this case, the mean, median, and mode is equal to 9. Okay. All the mean, median, and mode are equal. This is a special case when the distribution is exactly symmetric to each other from the left side and the right side. How to calculate the mean, median, mode we have already seen. So this is the set of numbers, and just calculate the mean, median, and mode yourself. Before we understand what is a sample mean and a population mean, let's see how median is resistant to the outliers. This is the same data set what we have already seen in the previous slide. Okay. So the entire data set is arranged in the ascending order. Now suppose these 3 numbers are changed. These are not 22 anymore. These 3 numbers are, suppose this is 61, this is 78, and this is 90. Okay. So the distribution, the arrangement of the number is still in the ascending order. There is no change at all, because after 21 it will be 61, then 78, and then 90. These are outliers because the entire data set was in the range of 4 to 22, but somehow suddenly some extreme numbers have been introduced into the data set, like 61, 78, and 90. These are the extreme numbers. They are no closer to the 22 or 4. So these are outliers. So that's the concept of the outliers. Okay. So once we have introduced these outliers in the data set, does that introduction of outliers going to change the median of the number? No. The middle point still remains 13. The middle point still remains 31. But it's going to change the mean of the number, the mean of the data set. So if I talk about median is resistant to the outliers, but mean is not. Mean is not resistant to the outliers. So mean is not resistant to outliers, because the moment we introduce any outliers, the mean shifts towards the outliers. Okay. So that was a very important concept between mean and median with respect to the outliers. Now understand what is a sample mean and a population mean. We all understand that what is a population. So population is a huge data set, and it is not practically possible to take each and every data points from the population. So suppose this population is 1 million population. Okay. And we cannot take each and every data set or people, suppose, from the population and then study their salary and take out the average salary. So what we do is we'll take a sample from the north, we'll take sample from the different corners of the entire population. Okay. And then on these samples would be the randomly picked up samples, and then we'll calculate the sample mean. So in a data science world, what happens is a sample is always denoted by a small x and a bar. Okay, so this is how it is shown. So this x and the bar, and the population mean is always denoted by a special symbol which is mu. So sample mean, which is x bar. So x bar, if I talk about this, is it, take the summation, and here will be xi, where I is equal to 1 to n. Okay, and then divided by n. So this is your sample mean, where x and I can be 1, 2, 3, 4, and it is going to n. So that's how. So this is your sample mean, and population mean can be mu. Mu is equal to, again, summation of xi, and where I is equal to 1 to n. The only difference is here is that in the population mean we denote by mu. In the sample mean is denoted by x bar. The sample mean, the number of items or the number of data points are shown by n, and in the population the number of data points are shown by bigger n. So that's the only difference. So that was the sample mean and the population mean. In case you have liked this particular video, please press on the like button and subscribe to my channel, and we are going to be posting more and more videos on statistics. Thank you.